live. Share my screen. Okay. Is anybody?
Yeah, we got 4 people waiting.
Oh, okay. Great. Can you see my screen?
Yeah. It's just delayed.
Oh, okay. Great. All right. Cool. So yeah, welcome everyone to the first LA PureScript Meetup. Welcome. Yeah. So this is great. Like, thank you very much for coming. This it's great to see such a good turnout. So I wanted to create the meetup because, obviously I'm interested in PureScript, but I want to see pure functional programming take off more in LA. We don't have all that much of it going on, and we have the Santa Monica Haskell group, and there's a couple of sort of related meetups in sort of the same vein, Papers We Love meetup and that kind of thing. And now we seem to have enough interest for a PureScript meetup, which is great. So now we have one more, and I'm hoping we can. I'm hoping we can, use it for teaching. Hopefully, there's enough of an intersection with the JavaScript community, and we can get people to come along and, learn some pure functional programming in LA. So just want to say a quick thanks to Lumi for hosting and providing the food and drink. Stefan, do you want to?
Yeah, you're here at Lumi HQ, which is, Phil and Brady, who's here, who's going to present in a second. We all sort of work together here. Raise your hand if you know what it is, or if you went to lumi.com at all. Okay, whoa, that's high turnout. Oh man, I didn't expect that. I thought it would be 1%. Yeah, so we make packaging for e-commerce companies. The software side of things, which is still pretty small, like 5 people currently working on the engineering side, is all related to basically the manufacturing and operations behind that, as well as kind of the design elements of how do you design packaging online. So we started about 2.5 years ago. We were a YC-backed company, so we've been at it for a couple years, and we're hiring front-end and back-end engineers right now. You get to work with Phil and Brady and a couple other people as well. So if you guys have questions after this, I'm happy to answer any and all of them about Lumi or the jobs or anything else. I run the kind of design and engineering side. Do you want this chair, by the way?
No, I'm
okay. I'll grab it.
Thanks.
But thanks.
All right. Cool. So yeah, big thanks to Lumi. I was going to say, please consider doing a talk. Let me know if you're interested in doing a talk or if you have a library. The way I was thinking of setting things up was that we could do like one main talk perhaps every week, and then every meetup, and then maybe have a lightning talk. So I'm going to give this introduction to PureScript, probably be about 30 minutes depending on time and questions. And Brady's going to give a lightning talk about the library he's working on. So if you want to do like a short lightning talk, that'd be awesome. Does anyone have any announcements? Jobs? Anything like that? Usually like to do something like this at the start. No? Okay. All right, so like I said, I'm going to start with this intro talk. I hope it's going to be like pretty relaxed, and I don't have all that much stuff to cover, so I'm hoping we can sort of fill in the gaps with questions and things, so please do just interrupt with questions. Okay. I am Phil. This is my Twitter. If you're interested in sort of stream of PureScript related tweets and, category theory and whatnot, then you can find me on Twitter. And GitHub, my username is PAF31. I created the original version of the PureScript compiler, if you didn't know. And now, I continue to work on the PureScript compiler and libraries. And, I'm heavily involved in the PureScript community online, Slack and IRC and that kind of stuff. I'm going to talk about why I decided to make the PureScript compiler, why you should use it, the libraries that we have available, the ecosystem, and how you can get set up if you're interested. So you can follow along. I don't have slides. It's just sort of like a long list of Chrome tabs. So you can follow along for most of this and give URLs, or at some point I'll have live coding in PureScript that you can follow along with as well. So obviously I work at Lumi. We're hiring, so like Stefan said, so let me know if you have any questions about what we do, the way we use Haskell. Okay, so this is the PureScript website, purescript.org. Okay, actually, let me start by asking what people use for front-end development. I'm assuming most people use JavaScript. I guess, can people show hands? JavaScript, cool. TypeScript, Flow, but anything else? Oh, ClojureScript, okay. I assume most people use at least a little bit of JavaScript, if only for interrupt, though. Is that accurate? No? People use anything else? Okay, so does anyone have any particular issues with JavaScript or the platform that they are using? I can tell you some. Well, no, I mean I can tell you some of mine. I mean my biggest problem with JavaScript is the inability to like reason about code, JavaScript code in the large, right? So I like JavaScript because I can do small things very quickly and get feedback very quickly, and I can view source, and I can quickly try things in Chrome and have the Chrome developer tools and all these nice things. And all of that's great, but it doesn't scale up for me to large code bases. And if you give me a large code base that's been developed by other people, I don't feel like I have the same level of comfort getting up to speed with that code as I would with Haskell. And that's a big part of why I created PureScript, and I like to think that it solves a lot of those problems. So the PureScript.org website has, if you haven't seen it already, it's got like links. We recently trimmed it down to just the bare minimum stuff, but it has an overview, a few sort of reasons why you might want to use it, and then resources to like all the stuff you need to get started, libraries, editor plugins, all that kind of stuff. So if that's like a really good first place to check out if you want to get it installed. I will try and do a tutorial in a little bit how you can get set up otherwise. All the what, sorry? Oh, on the front page? Yeah.
If there's questions, make sure to repeat them so we can.
Oh yeah, good idea. So Gary was saying it'd be good to add. Oh, I do. I think we took them off. Yeah, Gary was saying it'd be good to have a list of conference talks and meetup talks and things, which we did used to have on PureScript.org, but we have been moving stuff like that, which changes more rapidly to this documentation repository in GitHub. Yeah. Yeah, so it really is just like the bare minimum stuff, like one page right now. But it should have links to everything you need to get set up. And if you just want to try things and see some PureScript code that's not, it's a bit longer than this hello world, you can click try PureScript, and there's a whole bunch of links to actual code. Okay, so there's a lot of languages that compile to JavaScript, right? I don't know if you've seen this list, but this has been around a while. It's actually on the wiki for the CoffeeScript repo, but they started putting together a list of alt.js languages, so non-JavaScript things that compile to JavaScript. And, PureScript is in here somewhere, right? It's pretty long. And there's like, for every sort of type of programming you could wish to do, there's a compiler that does it, right? And there we are, okay. So it's probably pretty, oh, somebody updated it. We have the C++ back in. Okay, cool. So I guess it's up to date. So why would you want to use PureScript when there's all these different options? So I think, which category we're in? We're in static typing category. That's pretty good, right? I think that's one of the main reasons you would want to use PureScript. Okay. So about 4 years ago, I guess September, oh, almost exactly. So September 29th, 2013. I kind of cobbled together bits and pieces of like type checkers and parsers and code generators and whatnot that I had from other projects. And I had this sort of set of goals in mind that I wanted to solve with PureScript. And if you've seen the current compiler code, this is like, this might look kind of long, but this is really quite short by comparison to the, it was a very, very simple compiler when I started. Just a basic type checker, no really advanced type system features, although I think we had like row polymorphism and things. Simple code generator. The syntax has changed a lot, but I mean, a lot of the core ideas are still there. And I posted it on Reddit. This is the original Reddit post. And a lot of people seem to have, it seems to sort of solve the same problem that other people were having with JavaScript, which was that, people wanted this principled way to write JavaScript without, other things existed, GXC.js, Haste, for like, people coming from the Haskell community. But people seem to want the same things I wanted, which was simple code generation, generate sort of easily readable JavaScript using a strict language, minimalist approach to building a library ecosystem and a compiler. And it got a pretty good response, right? And we got our initial contributors that way, and community grew reasonably quickly. So nowadays, sort of like 3,000 commits in and something like 70 contributors, right? So it's grown pretty quickly. But I think a lot of the original design goals are a lot of the same ideas. I think all the same ideas are still there. So for me, the main design goals when I started PureScript were, like I said, minimalism. So I don't want a batteries included compiler or language library ecosystem. I like building my own abstractions, bringing my own abstractions to the front end. I don't want sort of bloated libraries of which I use 5% and then have this gigantic bundle that I don't use. So I like to mix and match small libraries. Another design goal was I wanted to use simple Haskell. So I wanted to really encourage, I definitely wanted to get contributors and to have this be, a Haskell project that beginners could easily, like Haskell beginners could easily contribute to. I didn't want a runtime. So a lot of the competitors that I'm going to go over in a sec, so Elm, JXC.js, Fay to a lesser extent, I guess, all have runtime systems that you need to build into your JavaScript bundle in order for anything to work. So I was coming from things like TypeScript and just raw JavaScript where you don't have any runtime system. And I wanted to take the benefits from that and keep that in PureScript. And I wanted strong expressive types. I wanted to be able to do a lot of the things I could do in Haskell, but in a strict language, in a strict setting, and get a lot of the same benefits. So be able to know at compile time that my programs were doing the right thing, and not have to worry about it at runtime and wait for exceptions to get thrown, dig through the logs, whatever, right? Like I wanted to know at compile time with certainty. At the time I was working on a medical application, so I had like a particular reason to want correctness up front. And finally, another design goal was like no magic in the compiler, right? Like everything should be predictable. Code generation should be completely predictable. I should be able to sort of look at PureScript source code and like with some work, be able to tell you exactly what JavaScript it would get turned into. But look at the JavaScript code and know, okay, there's an algebraic data type here, or this came from a case statement, or whatever, right? Like everything should be very predictable, and there shouldn't be any sort of magic built into the compiler for special cases or certain tasks that I would want to have the compiler support or anything like that. I like to build things in libraries, not have magic in the compiler. Okay. Any questions on any of that? No, but I think. Oh, sorry. Is Haskell magic in the sense of? No, I don't think. So if we're talking about JSON, I mean Haskell's expressive enough that like. Oh, is it magic? Like. Yeah. I don't know. I mean, I wouldn't say so. I mean, it's not magic. It might have unpredictable pieces. Like, I don't think template Haskell is particularly predictable in terms of code generation, for example. No, I'm thinking more like sort of code generation or macros or that kind of stuff when I talk about magic, or like if the compiler has something built in for like JSON serialization or something like that. Yeah.
There's a question from the live stream.
Okay.
From Craig
Great.
Gallimore, who asks, apart from the Learn PureScript book, are there any other good resources for learning about PureScript in some of the common libraries? Okay,
so the question was, for the purposes of this, well, I guess everyone on the stream can tell, but the question was, are there good resources for learning PureScript other than the book and for learning the libraries? Back. That's quite a bit. Never mind. Okay, PureScript.org essentially has links to all of the stuff you would need, but so there is the book. I'll show a little bit about the book in a little bit. If you like to learn from videos, there's a PureScript online community YouTube channel. If you like to learn from code, there's Try PureScript, which has a good number of code samples. There is the documentation repository, which has the old language guide, which is still pretty useful, but it's more of like, I guess, like a spec than it is a book. I don't know. Is there anything else? Nate, can you think of any? Yeah, join the Slack channel. Yeah, there's a really excellent community. Shouldn't forget that. FP Slack. I think you can. It's FP Chat, right? fpchat.com. You can join the PureScript channel there. Yeah, but all of this stuff is linked from either PureScript.org or the documentation repository. So you can find all that stuff there. And for core libraries, you can check out Pursuit, which is also linked from PureScript.org, which is an index of all the core and third-party libraries, which I'll also show in a sec. Okay, so like I said, at the time I was writing TypeScript, and I just want to talk about some alternatives and why I decided to write a language rather than pick one off the shelf. So there's languages like TypeScript and Flow, okay? And at the time, I guess, I don't even know if Flow was around when I started. If it was around, it was very, very young. But I was used to using TypeScript. And I do think TypeScript is a really great language for, compared to JavaScript where you have no types. If you like types, obviously like anything with types is infinitely better, right? So like TypeScript is much better than JavaScript, in my opinion. And I was writing a large-scale application in TypeScript, and I was getting a lot of benefit from things like record types, and they have structural subtyping, so that's a little bit like our row polymorphism. So you can do quite a lot with that kind of stuff. And it has classes, and they used to compile to something like JavaScript classes and interfaces. So if you're coming from like a C# or Java background, it was really handy, and I was able to get a lot done. But then I found myself wanting things like from Haskell that I was used to, right? So you have some form of abstraction in the form of interfaces, but I was interested in using type class style, polymorphism and abstraction that I was used to from Haskell. And I wanted real row polymorphism instead of structural subtyping, where occasionally I found the type checker didn't do quite what I expected. Row polymorphism seemed to me like, a much better option. More predictable, I should say. And it has the same, it has a solid theory behind it as well. And finally, probably most importantly, I wanted things like algebraic data types, which just at the time weren't available in TypeScript. And I think now you can do like, is it like you have like union types and string literal types or something, and you can kind of combine them together, I think, to get something like algebraic data types. But at the time, I didn't have them available, and they are like, between new types and algebraic data types, they're sort of like the most, the most commonly used like non-standard types that aren't available in your average programming languages, right? With like the most sort of bang for their buck. And I really wanted to have those available. Okay, on the other side, coming from like the Haskell side and the Haskell community, there are other projects like, for example, Haste, which compiles the best part of Hackage to semi-readable JavaScript. Actually, it's actually quite understandable, I think. Fay, which is, I think, a strict a compiler for GHC core or STG to JavaScript, assuming that the code you write in Haskell was meant to be strictly evaluated. Unfortunately, it doesn't include type class support, which was one of the main reasons I wanted to create PureScript. And GHC.js, which is probably the most commonly used Haskell to JavaScript compiler at this point. So based on the design goals, all of these failed to check some box in some way, right? In GHC.js's case, it was, readable JavaScript, the output from GHCJS is very large. It's not easy to read. And I wasn't able to take it and hand it off to a JavaScript team and have them sort of understand the JavaScript that I was outputting. And that was a big part of what I wanted to be able to do. Same problem with haste to a lesser extent. And my complaint with Faye was that it didn't have type classes. And also it failed, all of these failed the no runtime restriction, right? If I want to sort of bring my own abstractions and have very small JavaScript bundles, then not having a runtime is pretty important. And then there was another language that came to my attention called Roy by Brian McKenna, which was actually probably the biggest inspiration. And it sort of checked the most boxes that I had on my list. And I was very close to going with Roy. And I just had some sort of minor complaints about the way the foreign function interface worked at the time. And I think now it might be slightly different, actually. But, Roy was very, very close to being what I wanted. And another big part of it was that I actually just kind of wanted to see what it was like to build a toy compiler, right? So, but there was I was very close to going with Roy. And it's very similar to PureScript. It's well worth checking out if you haven't seen it before. I heard about it at the emerging languages. The first Strange Loop I went to, they had an emerging languages camp, and Brian McKenna was giving a talk about Roy, and that's where it hadn't dawned on me at the time that, if you don't like your programming language, you can always just go write one, right? So that's actually like a tractable problem. So that was a big inspiration. All right. Okay. Any questions? I don't think it is. I think there might be sort of maintenance going on, but I haven't checked in a while, to be perfectly honest. Oh, sorry. The question was, is Royce actively being maintained still? I haven't checked in a while, but I don't think they're adding new features at least, but I'm honestly not sure. Any other questions?
Nothing on their GitHub for 4 years.
Well, all right, there you go. Okay, so let me just say something quickly about features. How am I doing for time, by the way? I don't want to let this drag on. All right. Okay, so the most important features I think that PureScript has are its type system. And I spoke about how I want to know at compile time, not runtime, that things have gone wrong, right? Or that things will go wrong. The foreign function interface, so how to interrupt with existing JavaScript code. It's I said that it was important to me as a design goal to be able to take PureScript and know what JavaScript is going to come out on the other side. But by the same token, I want it to be really obvious. If I write some JavaScript, and I write it in a principled manner, like the PureScript compiler might, then I should be able to ascribe a type to it and just use it like a regular PureScript program. And that's what the foreign function interface lets you do. And small and simple code from the code generator. So we've tried quite hard, for a while to make sure that we don't have regressions in the generated code quality. There are certain things that certain features that if you use them, like type classes, for example, or some of the more advanced uses of type classes like functional dependencies or type level programming with type classes, that will result in, it's still predictable, so it doesn't sort of violate that design goal, but it does generate, it's a form of code generation, it does generate odd large code. So there are places where that's not true, but I think it's a feature of PureScript that if you use it in restricted ways, don't misuse those features, you can get very, very tidy JavaScript and actually just hand it off to a JavaScript team and have them be able to read it and interrupt with it. Okay, this is the documentation repository, and I was just going to quickly go over a couple of the type system features, just to talk about the type system. So PureScript has all of the primitive types and basic types that you would expect in a regular compiled to JavaScript language that mimic the types that you have available at runtime in JavaScript. So numbers, strings, booleans, and then some derived things like integers, which are special numbers, and characters, which are single character strings. Arrays, except in PureScript, arrays have to be term row polymorphism? Go over that real quick. Yeah, sure. So typically when you use records or classes or things where you have multiple fields, you might be used to using subtyping in order to talk about when one is more general than the other, when one has more fields than the other. Row polymorphism, on the other hand, is a way of saying, I have these fields and possibly some other fields, or I have this function that requires these other fields, but you can provide other fields too, and have a way to talk about that other stuff that you didn't specify precisely in the type system. So I think I have somewhere here, I have a try PureScript waiting. All right, so, sorry, I should increase the font size here. Oh no. There we go. All right. Okay, so I can say, actually I can give a nice demo of the code generation here. So let's say I want to print a name of a person, and it takes the person as an argument, and it's going to print the last name first, followed by a comma, followed by person dot first name. Okay, I do need prelude after all. Okay, there's a little warning here which tells you the type, right? So I didn't give a type annotation, so the editor integration and try PureScript will tell you the type, so you can fill it in. And the type is this thing that begins with for all at the bottom here. So it says for all T7, so T7 is a compiler-generated type name. For all types, let's say T, if you give me a record that has a last name that's a string, a first name that's a string, and some other properties that are identified by this type argument T7, then I'll give you a string. Okay, so I am able to say print name test is equal to print name of first name and last name, where first name equals Phil, name equals Freeman. And it's happy with that, right? But I'm also able to provide some other stuff. So I can say location. Okay. And that compiles just fine, because raw polymorphism allows me to absorb that extra location field, which I wasn't, I didn't care about, into that row type argument. Okay, so it's called row polymorphism because I'm being polymorphic in a row, i.e., a collection of types with names. So we use this for a bunch of stuff. It's not just used for records. We use it for effect tracking. So I can be polymorphic in the types of effects my function has. What else do we use it for?
Well, I think one thing that's important about row polymorphism is that you can also return. You can take a record that's polymorphic in tail aspect, but then you can return. You can change the fields, and then return that record again. So you're like an update over some subset of fields that you care about.
Yeah. So for example, if I want to move a person to LA, I can say that I just want to take all of the regular fields that, not the location, but the location is going to become LA. This has type. Read that? Okay. This has type for all T, actually two types here. The location, the first location can be any type, but it becomes a string. But the tail doesn't change. Okay, so I still have T17 in both tails. Okay. Sorry, for the benefit of the stream, Nate was just saying that it's not just a question of which fields I consume in a function. I can also produce records polymorphic in a row. Okay. Oh, sure. Yeah, it's kind of like that. Except you don't. So with row polymorphism, you don't care about the order of things, right? So it's not. Yeah. So it's a little bit like matching a list, but not in terms of like the order of the fields. Just just the names of the fields matter. I don't know. Well, possibly, but I mean, the type aspect is sort of the crucial bit, right? I mean, you can do this in JavaScript, right? But the important thing is, for me at least, is that the type system is checking that I'm not doing anything wrong as I'm doing it. So it's sort of an alternative to subtyping, like structural subtyping, but sorry, it's an alternative to subtyping on records, but the type theory is a little nicer, and you can do it with sort of regular, basic Hindley-Milner type inference, which is quite nice from an implementation perspective. Okay, just quickly go through the remaining type system features. We have tagged unions, that's algebraic data types that I was talking about before. So that gives me the ability to say something like data color equals RGB of R is a number, G is a number, B is a number, or a color can also be, you know, a HTML hex code or something that all specifies a string, or it could be like HSL, and I've got some other stuff in here. Right? We can have types that are made up of multiple alternatives, and in order to construct them, you choose an alternative and you provide the data that goes with it. And in order to consume one, you have to match all of the possible alternatives, right? So I would write a function that pattern matches on RGB.
Can you put like a constraint number between 0 and 5?
Not sort of. You can you can solve the problem you want to solve, but not exactly. Like you can't actually say this is between those values in the types, but you could create, for example, a like a smart new type where you don't expose the constructor, for example, and then you only allow people to construct those things if things fall in range. And I keep forgetting to say the question. Sorry, the question was, could R, G, and B be values that were constrained to only allow things between 0 and 255? Yeah, you could use like a smart new type or something, and then you construct a function will return a maybe, something like that, where it sort of fails in a type safe way if you pass a value that's out of range. Okay, so that's a very quick overview of ADTs. New types, which is just a way, like I was just saying, to ascribe a little bit more type information to existing types. Function types, obviously, and then some more advanced things like polymorphic types and rank-end types. That's sort of an advanced form of polymorphism, and constraint types. So that's the type classes feature that I was talking about earlier, and row polymorphism as well. So this is one of the documentation repo pages, and it goes into a lot of details about a lot of these things. And I don't think there's anything else worth saying. No, that's all good. So if you're interested in the type aspects of PureScript specifically, this is a good page to read. Come on. Okay, and here's an overview of the FFI. I won't go into detail here, but just quickly, let's say you have a JavaScript function like the power function on numbers. It takes two numbers and returns a number. It's really easy to import that into PureScript. So you can just, on the PureScript side, say foreign import and give a name, like pow, for power, and a type with a double colon. So it's a function from a number to a number to a number. So two numbers to a number. And then you have an accompanying foreign JavaScript module. That's just regular JavaScript with the same name. So it's math.js and math.pers, which is the PureScript file extension. And then you just export something in the standard sort of common JS style. Right? So you say exports.pow equals, and then because it's a function that's curried, I have to curry the function on the JavaScript side. But I do the sort of obvious thing apart from that, right? I take two numbers and I return a number. And I just delegate to the regular math module for this example. And you can also import, conceptually import types, right? You can say I have these foreign types that correspond to things that I want to do on the JavaScript side. And I'm going to use them via functions I import in the FFI. So that's useful for things like interacting with the DOM. I don't have a data type that's like an algebraic data type for DOM elements. And I can work with this conceptual like foreign type that characterizes those things. Okay. Wasn't going to go into I can show here just the last feature that I listed, which was the clean small JavaScript. I can just show the code that we generate for this module. So here is the, is this readable, by the way? It's okay, right? Okay, so here's the RGB constructor. Right? It's just it just naively takes the data you're going to pass in, which is this RGB record, and it just assigns it. It just creates this, what do you call it, like prototype or something on JavaScript, on the JavaScript side, like constructor class or something. I forget what they call it in Chrome, but Chrome does a good job of optimizing this, this way of storing data. And then I have one for RGB, I have one for hex code. And if I want to pattern match on these, then I can use the instance of keyword in PureScript, and that's how, which I'll just show you, is RGB. We can pattern match, right, and say that one's true, is RGB, that is false. Okay, if you look at the code for this, which is here, it'll just get turned into an instance of check, right? So if V, the input, is an instance of RGB, then we return true, where RGB is this little constructor here. For the record, sorry, raw polymorphism, it sort of just turns into the thing you would expect, right? So print name just uses regular record access on the person object I pass in. Regular string concatenation is just the plus operator. Record update is a little more interesting because we have to take account of properties that the user might not have listed, so we have to do this iteration over the remaining properties in the object. But apart from that, it's sort of exactly what you would expect if you're doing a record update polymorphically in JavaScript. So you can use this in try PureScript to just see what the code generation looks like, but you can just pop some code in here or take one of the examples and just press show.js and it'll toggle from running it to just showing you the code. Okay, any questions on any of that? Does anyone want to see any features? No? Okay, just want to say a little bit about the library ecosystem. If you want to get a feel for the sorts of libraries that are available, the best place to look is this website called Pursuit, which is a couple of years ago, Harry, who's one of our core contributors, worked on this website for the Google Summer of Code. And we keep updating it. We added things like type search and a couple of other nice things. It's open source on GitHub if you're interested. It's built with Yasode if anyone's curious. But it lists the most recent package uploads by version, and then an A to Z index of all the packages that people have uploaded. So there is a PureScript package for almost, you know, any standard thing you can think you might want to do in JavaScript. And if there isn't, then you can wrap it easily with the FFI, and people sort of continually build these things and upload them by reusing the work off NPM. Take something off NPM, use the FFI to wrap it and upload it as a package. I'll just say something quickly about some of the more popular libraries that people use. First I'll just say on here there's a subset of these which are called the core libraries, which are libraries that we distribute and keep in sync with the PureScript compiler, and they typically are things like that they are things that, you know, are sort of data structures and algorithms and standard functional programming machinery that you would expect to have available and that would work in any setting. So it would work in JavaScript in the browser, or JavaScript on Node, or JavaScript on AWS Lambda, or hopefully most of it would compile with one of the alternative backends, so you could compile it to like Erlang or Lua or something, and they should all just work, right? And then we have another organization that's called PureScript Contrib, which is it's slightly less restrictive. Things there sort of change slightly more slowly. They don't necessarily fall in sync with the compiler. And then there's repos under two more organizations called PureScript Node and a new one called PureScript Web, which are specific to, obviously, Node and the web. And then they're not categorized here, but then everything else is just sort of third-party libraries that people have uploaded. Okay, so here are some libraries that people have built in PureScript. Hyper is, I'll just read the title. It's a type-safe, statically checked. Sorry, it's the type-safe, statically checked composition of HTTP servers. So it's a way to build, web services and server-side rendered websites and these kinds of things in PureScript running on Node. Pardon me. So this library is pretty interesting. You know, it's sort of a standard web services library in PureScript that you might be familiar with from working with JavaScript, but it also does some stuff that is sort of special to PureScript. So in particular, it uses the type system to enforce some neat things like I'm not allowed to set a header after I close the stream or after I start sending the response stream down to the client for a response that has a content body or something like that. So we can use the type system to actually enforce those things. So if you're interested in web services, Hyper is definitely worth looking at. If you're interested in building front-end applications, we have like a wealth of options actually. One of the more popular ones is Pucks. So this is a wrapper around React. It emulates the Elm architecture in PureScript, or the Elm 0.17 architecture, I think. I'm not sure if they updated it for the new Elm architecture. And it's sort of a batteries included solution. So it has stuff for markup, it has stuff for dealing with events, for building components and writing things to components in the style of the Elm architecture, for building forms, for routing, for building CSS, these kinds of things.
So some of the things WebGL.
Mm-hmm. Yeah, sorry, the question was, is anybody doing anything with WebGL? There have been a number of attempts, I think. So some of the like lower level ones, I don't know if they're all maintained anymore, but some of the lower level ones would just give you wrappers around the functions that would, you take a shader, you compile a shader, like build a program, push the program to the GPU. It just gives you a low level way to do those sorts of things. And then some of the more advanced ones give you wrappers around all the sort of GL primitives, like draw this like vertex object or sends, but all those usual, like sending uniforms to the GPU, that kind of stuff. So there's one that was like Cogen from an IDL, and it's like really extensive actually. The actual like the WebGL IDL, so it has like every method. The one thing we don't have, which I would really like to have though, is the ability to like write GLSL in some like embedded domain specific language inside PureScript, but hopefully one day we'll get something like that. So another example of a library to build front-end applications is PureScript Halogen, which Nate knows a lot about because he's involved in a lot of its development. But I'll just give a quick overview, and we can talk about it later, hopefully. Halogen has its own virtual DOM implementation. It's 100% PureScript. It doesn't rely on React. It doesn't rely on virtual DOM or anything like this. It has PureScript all the way down to the virtual DOM implementation itself. It takes type safety very seriously, so you can't even add an attribute to a HTML element that is not supposed to be on that HTML element. It will actually use raw polymorphism to make sure you only use the ones that the standard says is okay. Did I get that right? It's still true, right?
Well, I mean, you can always circle, but yeah, the baked in DSL is constrained. Yeah, you can't add like a source attribute to the
Right. And there's a really good guide by Gary Burgess, who's another one of the Slam Data employees that works on this. And it goes over like how to build a component, how to compose components, how to do routing, these kinds of things. That's on the Halogen repo. Pardon me, if you're interested. And there's several other libraries for doing front ends. It's an interesting and challenging problem, right? So we have a lot of there's not one sort of batteries included thing that comes with the language that says this is how you should build front ends in PureScript. There's a lot of exploration of the design space going on. And I also wanted to just mention, sort of in the same vein as libraries, but that I mentioned briefly earlier, there are other backends being developed for PureScript. JavaScript isn't the only one. The two most actively maintained are Pure 11, which is a C++ 11 backend for generating native executables from PureScript, and it has its own set of packages that's maintained. And Pure Erl, pronounced that right? That's an Erlang backend, and people are working on porting a lot of the libraries to that as well, including people are talking about like Beam support and OCB and all sorts of other great stuff. And then there are various alpha quality backends that people have worked on, but less maintained. I wouldn't necessarily recommend using any of these in production or anything, but it goes to show that it's actually quite easy to add a PureScript backend either by forking the compiler or taking the intermediate representation and generating some other language from it. So things like Python, Haskell even, Clojure, Lua, Datalog even. So all sorts of cool backends. Okay, just quickly some applications so I can show you that people actually do use this for real stuff, not just category theory or what have you. So Slam Data is probably the most well-known and one of the biggest PureScript applications. It's 100% PureScript on the front end. It uses Halogen. Slam Data, in fact, developed Halogen. It's a NoSQL analytics solution for MongoDB and I believe other NoSQL databases. I think that's the adequate way of summarizing it. But it allows you to write SQL in a PureScript environment and in a PureScript UI and have that turn into MongoDB queries that get executed on MongoDB. And the entire front end, like I say, is written in PureScript. This is QuickType, which just got released. It's let's close this. It allows you to write descriptions. It's basically an IDL, actually, and then it allows you to turn. Let's see, let's Reddit maybe. So it lets you describe these descriptions of data and then turn them into various languages. So Swift, for example, and this whole thing's built in PureScript as well. I think they have like a TypeScript wrapper, so they interrupt with TypeScript as well. This is Insect. What's that?
I love that project.
Oh, Insect?
Yeah.
Yeah, I like Insect. It's really cool. Yeah, David Peter has a whole bunch of really cool stuff that he's written in PureScript, but this is one of my favorites. So this is a high precision scientific calculator with full support for physical units. So you can say things like 2 minutes plus 30 seconds and get an answer in either unit, or you can say 6 megabits per second times 90 minutes, convert that into gigabytes, and it'll type check these things in the browser and show you nice results. Okay. I will just show quickly how to get started, but I'm not going to give the demo because I don't want this to run over too much longer. If you want to get started, you have to install the PureScript compiler, which is just usually a binary download unless you're running some more esoteric operating system. But if you're on Mac OS or 64-bit Linux, I think people have had trouble with Arch, but most distributions of Linux will work fine. Or Windows, you can just download a binary and just start using the compiler directly. In practice, most people don't use the compiler directly. They use this tool called Pulp, which is a build tool for PureScript, written in PureScript. There's a nice Jarvis Cocker animation, if you like that sort of thing. And there's a really great guide. So this is maintained by Bodil and Harry, who I think this was started by Bodil Stocky, and Harry Garud maintains it these days. But it has a really extensive guide to how to do all these sorts of standard workflows, building PureScript, building documentation, uploading it to the package repository, what have you. There is, as I mentioned before, there's a book that I wrote a few years ago called PureScript by Example, which is, I think, 14 chapters with like 14 real-world things you might want to do, like building DSLs or using the canvas, or doing validation, like form validation, or dealing with like callback hell in PureScript using monads. And it's free. And if you feel like it, there is a donation you can make to children's coding charity. And it sort of goes over from getting set up and all the basics all the way through to sort of monads and monad transformers and more advanced things. And there is finally a getting started guide, which just goes through, it's like a sort of 20, 30 minute walkthrough of like starting your first project, testing it, building it, generating docs, these kinds of things. All the way from, installing the compiler all the way through to actually getting JavaScript and seeing it run in the browser. And that is, sorry, on the documentation repo. It's linked right from the first page, you'll see it. If you want to set up an editor, which I would strongly recommend, you should have a look at this editor and tool support page. The editor support is built into the PureScript compiler and distributed with the compiler. And there are then wrappers for most of the popular editors, so like Sublime, Atom, VS Code, Emacs, and Vim. I'm not sure if I missed any, but or you can use sort of minimal IDEs, which is the way I actually like to use PureScript, which just sort of watch your files and just tell you if you made any mistakes in the active file you're working on. So all sorts of different ways to plug into like your development workflow, and all that information's here. Anyway, I would, if you are going to set up a local development environment, I would recommend doing that. Before I just say about future work, just quickly would say, I've probably lost the tab, but try PureScript is the zero install, like lightweight way to get started and try stuff out. Right, you don't have to install anything to do this. Just go to try.purescript.org, and there's tutorials on various simple things like how to do recursion, how to use records, whatnot, and then there's alternative backends for try PureScript that let you try out different libraries. Like the latest one I added was the behaviors backend. So this is like a little FRP implementation in PureScript, right? We're doing little graphical things. So you can test out different libraries and try PureScript. And for the future work, I just want to say we're very close to, I think, 1.0. The next release is going to be 0.12, which has a lot of cool stuff for like type level programming and some sort of syntactic features like applicative do that we're borrowing from Haskell and GHC. But we're sort of very, very close to a 1.0 release. So I'm really hopeful that, I wanted to say it by the end of the year, but realistically it's probably going to be a little after that. But that we can get 1.0 out and things will stabilize, and that people will be keen to start using PureScript because all the APIs are very stable and this kind of thing. So that's my immediate concern is getting to 1.0 and stabilizing things. After that, there's always cool type systems stuff we want to add, like GADTs and new forms of polymorphism and things like this. So we'll probably end up working on those. New backends, in particular, people want an ES6 backend rather than compiling to ES3, which is what we do right now. What else were we planning? Can you give anything? I think those are the main things. Oh, optimizations. The current code generation is very predictable, but doesn't do much in the way of optimization. So inlining in particular, if you have a lot of type class heavy code, would be really nice for not having code generation be it gets very unwieldy. So we're hoping to do some work on specialization and inlining at some point. That's about all I've got, I think. Does anyone have any questions on any of that?
So for in your experience, if someone stacks like an existing JavaScript, for instance, and you wanted to try PureScript for some particular problem, in your experience, is there something that for type of problem a lot of people use it for, if they're just kind of dropping it into an existing project?
Sure. So the question was, what's the best way, and what are the techniques for adding PureScript into an existing JavaScript project? So when I started PureScript, the way I always thought people would do this, rather than sort of writing entire applications in PureScript or rewriting entire applications, I always assumed people would use it for like DSLs, like small. So for example, one thing I wanted it for was to write like what essentially was like a SAT solver, I guess, like a constraint solver, I guess. And I would have like a little PureScript thing that was this DSL. And it would take constraints and it would, present this nice functional API, right? Like constraints go in, solutions come out, and use the FFI to sort of give that a nice type on the JavaScript side, so maybe it uses records or arrays or what have you. And I still think there's a lot of potential for that, especially since there's like no runtime and the code generation is sensible, right? People in practice don't really use it that way, and they tend to pull in, relatively heavyweight libraries. No, I don't want to say heavyweight because that sort of has like negative connotations, but like it's certainly not like minimal JavaScript that comes out, right? Like you have like a lot, the bundle can be quite large even for relatively small problems. That's typically how people will do it. They'll sort of replace data structures and things like that, like incrementally, and then use the FFI to like bridge between the two. I actually recently did a screencast thing where I tried PureScript itself was used to be written in all JavaScript with jQuery, and I rewrote it to use PureScript, and I did it by using the foreign function interface. I basically dumped everything in a big foreign module and then sort of peeled off little bits of functionality and turned them into PureScript. So point is, there's a whole bunch of ways to do it. Most of them involve sort of leaning quite heavily on the FFI. Yeah, in practice, it's a tricky thing to answer because it depends a whole lot on the application. But there are good tools to facilitate it, I think. But it's not the best answer in the world, but yeah. Any other questions?
I'm curious, what drives the compiler features? So there are people using it right now. Do they define that they drive, or they're fine with what they have and they're just using it? Or who's driving the?
So at the start, it was sort of, I started by trying to. Oh, sorry. The question was, what drives compiler features, and how do we decide what to work on? So at the start, I was just working on the sort of nabbing the features from Haskell that I wanted in my language, right? Now, there's still some of that, right? There's, there's this cool, applicative do, for example, right? There's this cool thing, I use it in Haskell, and I really would like to have it in PureScript because I want to, I know it's, useful, right? And I wonder if I can implement it, and people work on those sorts of things. And then, there's just sort of, there's just features that sort of fall out of we're using the language all the time, and it just turns out that something, we just find this new thing. Haskell doesn't inspire all of the features. It's distinct from Haskell in a lot of ways, right? It's a strict language and what have you. So we find features that we want, and we start working on them, and we add them that way. There's a lot of sort of experimentation that goes on. People will try sort of, interesting things, and some things will fail. We don't sort of take all the experimental patches, right? A lot of stuff, people will just sort of start working on something and it'll turn out it's actually really useful, and we'll add it in because we want to foster experimentation in the compiler development. But sometimes, for a good example would be the C++ backend, right? We had that hasn't been merged back into master, even though it's a genuinely useful piece of code, right? Because it sort of makes sense for it to exist in a fork. So there is development that goes on as well in parallel. That, while cool, is not sort of in line with the original project's goals, and might sort of become one day, but isn't right now. So it's, stays separate. Yeah, sure.
Okay. So you showed how RGB translates into JavaScript. How does that translate into JSON? How do you just deal with JSON?
Okay. Sure. So the question was, how do you deal with JSON by comparison to how I showed that we deal with things like ADTs, like RGB, where you had a record, for example. So there's a whole bunch of JSON libraries. Some of them are sort of more use more interesting type system features than others. The most basic way, I think, is you could just sort of define a data type of JSON values. I mean, JSON, there's only certain types of JSON values, right? String numbers, booleans, records, arrays. Is that it? What's that, sorry? Oh yeah, sorry, objects and arrays. So you can just sort of define a type of those things, right? And then, give a nice type to JSON.parse, give a nice type to JSON.stringify, and write some wrappers like ASON has to take the untyped representation back and forth to a typed representation. So some libraries do that. And then the nice thing about having, actually working in JavaScript is that JSON values at runtime are just JavaScript values, right? So you can actually use JavaScript to do traversals and things on JSON values. So Slam Data has a library called Argonaut, and they do some, they allow you to do traversals on JSON objects. Let's say you want to dig in and find something deep in a structure, but in such a way that you do it on sort of the original values themselves, right? And then there's various approaches with generic programming. It's like a technique we borrowed from Haskell. You can use raw polymorphism in some advanced ways to give like really nice APIs to JSON when you're only dealing with records, for example. So there's various ways, you know, and there isn't sort of one standard library, but it depends sort of exactly what you want to do. Sorry, so some of the libraries specifically, if you're interested, are Argonaut, foreign generic, simple JSON, which is the one that I said uses raw polymorphism, but just record access. I think those are the main three. Yeah. Any other questions? No? All right. Cool. Do you want to use just use this? All right, let me just close this because
It's a lot of tabs.
yeah, it's going to take 10 minutes to close them all.
So I'm just going to talk quickly about like using Cogen in PureScript from Haskell types. So let me. I think I called it bridge talk. Yeah, all right, this is a sensationalist. It's not really bringing sanity to single page apps, but so this is like one thing that help. I don't like writing SPAs, but oftentimes you need the interaction of a SPA, or heavy interaction. So I'll just get right into it. Like, okay, so if you have a Haskell API and you're writing a separate front end for it, like you don't want to rewrite all of your types that you already have defined rigidly in Haskell, right? So if you have, if you want to write a PureScript front end, then I'm just going to show you one way of doing it. PureScript Bridge is, it's actually a backing library of another one, but it allows you to Cogen PureScript from Haskell types. And I find it pretty useful for this sort of thing. So some of my goals, these are the like personal goals. Like I want to write less code because I don't want to do a bunch of redundant stuff. Stay sane is more so just like a comment on how SPAs sort of are this insane, like, all right, I'm not going to go into that. But anyway, so the real goals are, I always want to, in my front end, I always want to build correct interfaces. And I know what those interfaces are because Haskell has defined them. So I want to use those. And then I want to ensure handling all the responses from the server. So I know what data types I have on the server side. I want to use those to actually unwrap my types in PureScript. So my first example is just going to be forms. Like every site has tons of forms. You want to be able to like input data and receive it into some form in the back end, right? But your form in the back end is a database expectation that isn't, it's not one-to-one with what you're asking from your user, right? So you have this subset that you want to express, and usually it's very small and simple. So what I would do is just define these form types, right? That, like this one, for example, is a curator. Like you want to input some curator's detail and send them an email, right? All you need is an email and possibly a personal message for them. That's fine. You take that on the back end and then morph it into this, right? The database representation is different, so you want to generate code to handle curator forms, right? Anyway, yeah. So like an example of using this is, I believe this is from Halogen, but it doesn't really matter. Basically, you have an initial state with a form object, which is of your curator form type. You give it some initial values, and you have these fields that you're filling in. You have validations or whatever, and it might look like that, right? So this is an invalid email because it didn't pass email validator test. So yeah, just generating simple forms. And what I like about this is that I know that this will always be right. Like if I remove message from the back end, like I don't want that in the form anymore, then this will be gone, right? Like the compiler will fail and tell me like,
why did you give me this other field? That's not useful. And then I can avoid having failing requests. Like I don't want to deal with that stuff. So this sort of gets rid of that. The compiler will tell me what's valid because it's literally providing the type that I'm using. Yeah, and the development flow is actually pretty nice because the Cogen is shoved, like when it grabs your settings, like I'll just write it off to the file. When the file changes, the PureScript will rebuild. So yeah, that was one of the goals. Like I just want always correct interfaces. That's simple enough. And then serializing response is like you have some possible scenarios that happen on the back end. You serialize them into some type. This like a simple example of what might happen in a create response. You get these things, you coalesce them into one type, pass them back to the front end, and use that type to unwrap it, right? So this is an example of a possible post you might have. Oops. Right, so the state.form is actually just your curator form type. It's just, you're encoding that, sending it up, and then we have a relatively general handle create response because it's simple. And then we show a flash message. But yeah, so the handle create response, I'm not even going to go over the translation stuff, but anyway, this is some generic type that you can handle every create response because you know it handles all the cases. It's just wrapping it back into a pair of status and string, and the flash message is, like I want to choose which color this is based on some, CSS property or whatever. That's all pretty simple as well. And I think really those two things for me, like that's enough to introduce Cogen, because it's not a big deal if you already have PureScript and then you know that this is like a tiny subset of the types that you might have defined in Haskell. But like these ones are the direct pushes across the network, right? So it's nice to have those. And okay, so this is the Haskell part. Everything else was mostly PureScript, but like in order to do this, this is using PureScript Bridge. We're registering these types at the type level with the proxy. If you don't know how that works, ask someone else, because I honestly don't know. I just used it. And it works pretty well. So our backend types are converted to equivalent PureScript objects, but they don't always, or PureScript types, but they don't always represent one-to-one relationships. So sometimes you have to convert things like this, for example. You probably have like an int64 primary key on certain types. You sort of just like, this is just saying I have a PureScript type that's an int, just to represent it that way. So anytime it sees int64 in your Haskell, it'll represent it as an int on the PureScript side. These are called bridges, I guess. So this is a different example where on the Haskell side you say I promise to implement this on the PureScript side, and this represents like, so the type module parameter is where it is located in your PureScript code base. What's it going to be called, and then what packages are required to actually use it. So I think by default, like profunctor lenses is required because it gives you a bunch of lenses by default. But anyway, yeah, so this just says the same thing as the other one did. When you see UTC time, fill it in with this PS date time type. And that'll add imports and stuff to create your types. And then really at the end, you're just saying, write these PureScript types out to this directory. And your bridge is composed of a few different bridges, and you're good to go. Like this, hooking it into the build chain is really all you have to do at this point. Like you just run main, and it'll write the files out, and then you use them. So that's pretty much it. I found it to be pretty painless for doing like a simple SPA, and I think honestly it should get it should get much easier after you define all the bridges. Like I only had to deal with UTC time and in64. There's probably a bunch of other things that you'll end up hitting that don't directly correlate. And yeah, so thanks. I mean, I would love to field other questions about it, but really that's the gist of using Cogen to generate PureScript from Haskell types. So.
That's all I got. Yeah, so one thing I forgot to mention last time is should probably do this once. Okay, oh, right.
One thing I forgot to mention last time is we'll probably do this, probably aim to do this once a month, like the Santa Monica Haskell group, and hopefully not overlap with that meetup. So like I said before, you know, please think about if you would be willing to give a talk. There's a whole bunch of, I'm hoping, like I said, we can invite, you know, some of the JavaScript community members in LA to come and learn some pure functional programming this way, right? So there's a whole bunch of beginner level topics. If people want to take one of those, and you know, we can put together a series of you know, beginner introductions to PureScript, maybe intersperse it with some more advanced stuff as well if people are interested in that. So that's about all we have. I think there was some chat about going to Arts District for a drink or something, or so we have lots of beer left. So I don't know what we're going to do next, but that's about all we've got.